This video is going to help you identify what is meant by free fall, Goal 5. All the information you need for the 4 test questions is written right here in these 2 paragraphs. So I'd highly recommend that you read them, but I'm going to kind of explain them further. The first question, number 13, what is little g used to represent? Well, little g is not gravity, as a lot of people would like to think, but it's basically the acceleration due to gravity. Right here. Gravity itself is a force that pulls all things down towards the earth. And the rate at which that force acts is the same everywhere. It's a constant value, and we use little g to represent it. So little g is the acceleration due to gravity. It has a value of 10 meters per second squared, if we round it off. So 10 meters per second squared. How did we measure little g in class? Well, we used a video, and the video showed some people dropping a basketball out off the top of a building. So basically, if we just kind of summarize the steps that you could do this, or anyone could do this, if you were able to take that video. So you're going to take a video of a falling object, and it could be just about anywhere, but we used a basketball dropping off the roof. So take a video of this. The next thing you need to do is you're going to need to track the points. And I don't know if you remember this, but when we dropped it, and I'm going to draw a little picture of it, okay? If this is the basket, this is like, say, the building, and here's the basketball, and it's going to get dropped down, all right? Basically what we did is we said, all right, at a certain time, say at 1 second, the ball has fallen to here. And now it's located right here. All right? So you're going to track these points. After another second, the ball goes a little bit farther. Because at that 1 second point, it's actually going to be going 10 meters per second. After another second, it's going to be going, after 2 seconds, the ball is going to be here now, and it will be going 20 meters per second. Because that's what this means. When things accelerate due to gravity at a rate of 10 meters per second every second, it's going faster by 10. The next one, you're going to travel even farther, though, because you maybe noticed with the dot location on the graph, the dots got farther and farther apart. So after 3 seconds, you're now going 30 meters per second because you're going faster. So you're going to be able to cover more distance. And yes, again, if it kept going 4 seconds, it would be going 40 meters per second. So basically, how did we track little g in class? We took a video of the falling object. We tracked the points to get basically velocity and time data, and we then graphed it. So you graph, and we had the program do it for us, but you graph velocity versus time. And then after that, you're going to find the slope of the line. And it turns out that you guys, I think, know this, the velocity versus time graph, if you find the slope of the line, so say at 1 second, they're going 10. At 2 seconds, they're going 20. Right? At 3 seconds, maybe they're going 30. So basically your graph is going to look like this. And if you find the slope of the line, what you're doing is finding the change in the y direction over the change in time. And if you remember, that is the equation for acceleration. Change in velocity over change in time. So the slope of a velocity versus time graph is acceleration. So if you look at my little picture over here, you can answer the next 2 questions very quickly. What happens to the velocity of an object in free fall? Well, the velocity increases. It started up here at rest. Here it's going 10 meters per second, 20, 30, 40. So as things fall, they increase their speed. But acceleration of an object in free fall stays constant. it is always that 9.81 meters per second every second. And you can tell by looking at a graph. The graph turns out to be a straight line, and so the slope of the line everywhere is the same value of around 10 meters per second squared.